So in this case, an object has 1200 joules of gravitational potential energy. So this is going to be PEG and a mass of 13 kilograms. So this is going to be our mass. We want to know the object's height, which will be our h. Okay, so pretty straightforward. We're going to obviously be dealing with the equation PEG is equal to mgh. Okay, so in this case, we know that the PE, now I could rearrange it to solve for the height right now. That's one way to do it, just without putting in numbers, and that's the preferred way. But if you're just starting out, it might be easier to visualize this by just putting in the numbers and then solving for what you're trying to find. So PEG, it tells us, is 1200 joules, and we know the mass is 13 kilograms. We know that gravity, G, so this is always a given, so I'm just going to write this here. Gravity is 9.8 meters per second squared, and that is always the case on Earth. So that is going to be right here, 9.8 meters per second squared, and we just don't know the height. So we're going to have to solve for this. So I'm going to simplify things a little bit. 12 is 1,200 joules is equal to, so 13 times 9.8. So put in my handy dandy calculator, and I get 127.4. So 127.4, and the units end up being kilogram meters per second squared, and that's going to be times height is, and so now we just had to get height by itself. And so since this is being multiplied, we need to undo that multiplication. The inverse of that is to divide. So I want to get h by itself. I want to get this 127.4 kilogram meters per second squared out of there, cancel that all out. Okay, but whatever I do to one side, I have to do to the other. So 127.4 kilogram meters per second. And so if I take 1200 divided by 127.4, I get a height equal to 9.4, and the units end up canceling out and leaving us with just meters. That will be our height. Okay, I noticed at the last second that I asked the wrong problem. I wanted to ask a slightly different one. So you'll notice that the problem down here has changed from the previous example that was on the screen before. We have 9,500 joules of gravitational potential energy. So this is going to be our PEG. We have a height of 8 meters. So height is h. That's how high up it is. And we want to know the object's mass. So that's going to be m. So we are going to be dealing with the equation once again because of the gravity. The gravitational potential energy of PEG is equal to mgh. All right. And like above, we're given the gravity, the energy, the gravitational potential energy of 9,500 joules. And that's going to be equal to our mass, which we don't know, times gravity, which we do know. That's going to be our 9.8 meters per second squared. Multiply that times the object's height, which is 8 meters. And we're good to go because we only have one variable left. Now we need to clean this up because, again, we're just starting out and we could have rearranged all the variables before, but just to see what's going on here, we're just plugging them in as they are. So cleaning it up, I'm getting 9,500 joules on the left-hand side, and I'm going to need to take 9.8 times 8, and it's going to give me 78.4. So 78.4, almost messed that up. Well, still kind of messed it up. And the units are going to be meters squared per second squared, just because that's how it works out, times m, because we still don't know m. That's what we're trying to find. Now I want to get m by itself, and once again we're multiplying. So what do we got to do? We have to divide it, okay, to get rid of 78.4 meters squared seconds squared. And that will make sure that cancels out, leaving us with just m on the right hand side. But whatever we do to one side, we have to do to the other. So 78.4 meters squared seconds squared over here. And what that's going to leave us with is going to be just meters because of what joules is. Joules is a combination of other units. It's a derivative unit. So 9,500 divided by 78.4, and that leaves us with a height of 121. We'll just say 0.2, because that's all I have room for. I don't know why I wrote the equation sign earlier. And tell you what, I think that's very sloppy. Let me rewrite that. 121.2 meters is equal to that's actually kilograms. Man, I'm just messing this up left and right. All right, so I don't like that at all. And you know what? I'm going to redraw my box because I screwed that up a lot. See how making it nice is just, or legible is going to be very helpful. So 121.2 kilograms is our mass once the units cancel out.